Good evening, student. Today we are going to learn about the organic compound or compound of carbon. So how this compound of carbons are classified, or what is the specific name given to the compound of carbon with hydrogen. So compound of carbon with hydrogen called hydrocarbon. So we will learn about hydrocarbon, and in addition to carbon and hydrogen, there may be some other atom inside a molecule or inside an organic compound. Then that compound is called as its derivative. So today we will learn about hydrocarbon and its derivative, then how these hydrocarbons are named. Those things we will learn. A student, let us start. What is this hydrocarbon? So we have learned, if we start with the organic compound, so we had written earlier, organic compound means it is the compound of carbon, hydrogen and other atoms which must be bonded with covalent bond. So it must contain the covalent compound, the covalent compound of carbon with hydrogen and some other atoms it may contain, hydrogen and other atoms like oxygen, nitrogen, phosphorus, halogen, these things. We have learned in the functional group. The functional group may contain oxygen as OH, or may contain oxygen with the ketone and aldehyde and carboxylic acid. It may contain nitrogen in nitrate group or cyanide group, those things. So a student, all these organic compound can be broadly classified as two categories. One is called as hydrocarbon. So write this as the hydrocarbon. A student, just for understanding, this hydrocarbon are the organic compound that contain carbon and hydrogen only. Hydrogen only. This carbon and hydrogen is present in the molecule. The other group is called as derivative of hydrocarbon, or simply derivatives, or hydrocarbon derivatives, or derivatives of hydrocarbon. So derivatives of hydrocarbon are those in which one of the hydrogen atom of hydrocarbon is replaced by any functional group or any heteroatom or any different atom. Like we had learned, methane is there, but one of the hydrogen is replaced by chlorine, it becomes chloromethane. So chloromethane is a derivative. So right, it contain at least one different atom or one atom other than hydrogen, and at least it may be more than one, other than or in addition to, better term is in addition to carbon and hydrogen. To carbon and hydrogen. Let us first understand the example. Example, if we are writing the methane, says CH4, it is methane. If we are writing CH3, it is called as ethane. If we are writing C2H4, it is called as ethene. If we are writing C2H2, it is called ETHYNE. So number of hydrogen is reduced, ANE, ENE to YNE, because carbon-carbon bonding is being increased. These are the examples. Means the compound containing carbon and hydrogen are called as hydrocarbon. Now, considering the isomerism and considering the catenation property, there could be different kind of carbon chain in this hydrocarbon. So depending on that, this hydrocarbon may be classified into different category. One is called open chain. Another one is called cyclic or closed chain or ring structure. The third one is ring with a special feature, okay, containing double bond at alternate position. That is called as aromatic. Okay, this word is just this word you have to keep in mind, not incomplete. I mean, you need not go in detail, but you just keep in mind aromatic compound. Aromatic compound. Okay, it is like this. It is one thing. Considering the chain, we can make it as the open chain or closed chain. Means open chain hydrocarbon or open chain compound. I mean, this is cyclic compound or ring containing compound. It is called as aromatic compound. A student, aromatic term, let me take one example to understand this. If you are writing, say, C3H8, it simply means CH2 is attached with other CH2 is attached with other CH2. Many a time this structure may be drawn like this. It is representing one bond, one C here and other C here. And this C is attached with only one. So if you are writing only this much structure, it is also the short form or line structure of this C3H8. These are the three. A student, it is like this. But if we consider the cyclic like our C6, then H12, though alkene is also possible. So this can be our the 6 carbon. This we have learned earlier. But at each of the carbon, there are 2 hydrogen. To fulfill the tetravalency of carbon. So this is the structure of C6H12. Okay. So in ring there is no double bond. But this aromatic is a different kind which must contain this unit. Say C, 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 this, and at the alternate position there must be double bond. So this unit must be present. Means at this position for tetravalency, hydrogen only. Hydrogen, one hydrogen only. So the compound containing this ring having double bond at alternate position, this ring have a special feature or unique feature which give rise to aroma smell. Means a sweet smell. Whatever sweeter we are eating or essence we are observing, that contain this aromatic. Not only benzene or this structure, but one of the hydrogen may be replaced by their derivatives also. So student, the molecular formula for this one is C6H6. So this structure C6H6, this have a special importance, and this ring structure is given a special name called benzene. Okay student, so it is the benzene ring. It is possible to remove one hydrogen, say this hydrogen can be removed, and other group like CH3 may be placed here. Then it is the derivative of the benzene itself. So let me write, this structure is called as benzene. But student, like here I was writing one structure where one of the hydrogen of this benzene ring is replaced by a methyl group. Consider this, the hydrogen is present everywhere and double bond at alternate position. A student, double bond may be drawn at any position, just at alternate position you have to write. Double bond you may draw with this way, or double bond you may also draw like this, exclude this at these positions. So the thing is that double bond is always present in alternate position, but this double bond can be in these positions also, like it can be at these positions. If we are considering at these positions, then these positions have to be released, otherwise the tetravalence is not satisfied, it becomes pentavalent. So this structure, this is the benzene. It is possible to remove some of the hydrogen from here, like this hydrogen, any of the hydrogen. Students, in this case all these 6 hydrogen, they are identical. Okay, so these are the identical position with respect to ring. So we are able to remove any of this hydrogen by some other group of atom, okay, or even the methyl group or any open chain hydrocarbon or the alkyl group. Say, considering the top hydrogen, I'm going to remove this hydrogen by another CH3. What is that CH3? This CH3, which is attached with one of the carbon of benzene ring, benzene. So this CH3 at the top, which is outside this ring. Keep in mind, student, this is outside this ring. It is this one. So this is the methyl group. Last day we were discussing from methane, if one of the hydrogen is removed, it is able to attach with the other. It is called as methyl group. So it is attached to benzene. So this one means one of the hydrogen is replaced by this methyl group. Then, a student, when one of the hydrogen is replaced by this methyl group, then this new structure, which is having double bond at alternate position and containing 6 carbon, means the benzene ring containing. So this structure is now called as toluene. So sometime, or even in NTSE, what is the structure of toluene? It is asked, and once it was asked, what is the name of this compound? So this compound is called toluene. A student, you have to keep in mind, this is the toluene. Like benzene, it is called as toluene. Benzenes, a simple benzene is sometimes also called as simply benzene. ring. So this benzene ring containing compound are falling in aromatic compound. So this is toluene is also aromatic. Means for the aromatic, the important thing is that it contain a benzene ring. That is the importance. Contain a benzene ring in their molecular formula. In addition to benzene, there may be some other. It may be possible that the second hydrogen may be replaced by the C2H5. It's also okay. That will be the other kind of aromatic compound. Getting a student? So it is this one. Means benzene ring containing or 6-carbon cyclic compound with alternate double bond is called aromatic. It gives rise to a unique feature. Why that unique feature we will learn in class 11 and 12, that this double bond give rise to a characteristic called resonance. So this benzene can exist in two structures, either double bond at this position or these double bonds may be drawn in their alternate position, like here, here, and here. If it is drawn at these yellow positions, then these blue positions have to be released or have to be removed. Okay, so both of these structures are possible, and these two structures are called as resonance of each other. Okay, or resonating structure. Like isomers, it is the resonating structure. This gives the stability to the molecule, and that molecule is very much stable, and that gives rise to another characteristic by which this hydrogen can be removed easily. Okay, these things are beyond to your scope, so I'm not going to discuss this thing. So you just leave this. So you just understand this much. The carbon means 6-carbon containing cyclic compound with alternate double bond is called benzene ring. Okay, or benzene. And if hydrogen is replaced by the other compound, that is also of the same category. So this category of compound is called as aromatic compound. Okay, student. So these were the 3 examples that I had taken, for one for each, or 2 we have taken for this aromatic compound. So if you want to write for this toluene, then this C2H5 have to be written together. So it is like our C6H5. This C6H5 is obtained from C6H6, C6H5, and after this methyl group or from methane, removing one of the hydrogen, methyl is obtained. So that is our CH3. It is written after this. So molecular formula of toluene is C6H5CH3 in this form. Okay, it is this structure that you need to verify. So to avoid the confusion that whether it containing the ring or not, we are always drawing like this. For drawing the simplicity, means every time writing the 6-carbon putting hydrogen, it becomes difficult. So therefore this ring is represented by drawing this hexagon structure with alternate double bond in these positions. It is this. It is this representation. Sometimes this alternate double bond may be in the other position also. So therefore the position of double bond is not fixed. Therefore inside this we are putting a circle itself. So this is the symbol of benzene. Getting? So many a time just this structure is drawn and it is asked what is represented by this symbol. So this symbol represents benzene, whether 6-carbon with alternate double bond or hexagon with a circle inside it. So what will be the structure of toluene? So in symbol form, the structure of toluene will be like this. So you have to draw the hexagon, draw it, and in this hexagon, at one of the position, any position, because all the carbon are identical, you can put this CH3. So this is the structure of toluene. So in different years, even in your academics also and in NTSE also, This complete structure with CH3 is given. The question was asked, what is this structure or what is this compound? Many a time the symbol was given and it was asked. So all these things are very important. Student, do not forget this. So regarding aromatic compound, this much is enough for you. Okay, we will learn more about this open chain and cyclic. So a student, it may be possible that one of the hydrogen being replaced by the chlorine, then it become, the structure become like this. See, one of the hydrogen is now replaced by chlorine, putting like this. So this is called as chlorobenzene. Okay, chlorine is used as prefix, so chloro, and it is the benzene. This structure represents this C6H5, in which from one carbon of benzene, hydrogen is replaced by the chlorine. So it is chlorobenzene. It is also aromatic, but it is falling in the category of derivative. So derivative of aromatic compound. Get it? Now, a student, considering the aromatic which have the benzene and double bond, there these other two categories like open chain and cyclic, they are also called as aliphatic. Okay, so aliphatic are relative to the aromatic. So these are our aliphatic compound. This aliphatic will not ask in your examination mostly, or they are rarely asked, but while you will go through the different notes of different coaching, you may come across this too. So that's why I have told you aromatic, if the compound is not aromatic, it is falling in the category of aliphatic. Okay, student, it is this one. Aliphatic include your open chain or the cyclic chain. Okay, it is this one. In this cyclic, we had also drawn the other structure. One of the hydrogen can also be replaced by the another methyl, ethyl, or all these groups. So it is this one. Now here we can also, or this cyclic or open chain can also be containing only carbon-carbon single bond, or carbon-carbon may have the double or triple bond. Get it? So based on that feature, these aliphatic or these open chain and cyclic, they are classified into two categories, means both of them. One category is called as saturated, which contain carbon-carbon single bond only. So they could be saturated. The other category is called as unsaturated. It may be this one. A student, keep in mind, this aromatic compound, which is containing the benzene ring, it also contains the double bond. So these aromatic compounds are also kept under the category of unsaturated. Okay, so many a time even this hydrocarbon itself is classified into two categories. One is called saturated, another is called as unsaturated. So draw that structure also. So hydrocarbon may be classified into, now this classification is based on carbon-carbon bond. Earlier classification was based on considering the ring or open chain or benzene ring. That was the basis. Now considering the carbon-carbon chain, so carbon-carbon bond, so you may write here, so it is based on carbon-carbon bond. A student, bond means carbon between two carbon, single bond must be there. If some of the carbon contain double bond in addition to single bond, then they are called as unsaturated. So therefore, these can be broadly classified into two categories. The very first is called as saturated hydrocarbon or saturated compound, you may write. Another is called as unsaturated compound. Students, saturated compounds means between two carbon there is only and only carbon-carbon single bond. So only single bond between the carbons are found in such compound. Means only there will be a single bond between two carbons. Here, in this case, in addition to single bond, at least one of the double or triple bond should be there. So, right? In addition to single bond, or even without single, or even without containing single bond, it may be, or may containing the single bond, or without single bond. So this without single bond is obtained in ethene and ethyne only, or without single bond it may be like this one also, but mostly it is in addition to single bond, at least, means not for the all carbon, at least one double, maybe the double, or maybe triple, or maybe both, or triple bond between two carbon is present. Then it is called as unsaturated. A student, for this you have to understand carefully, you have to draw the structure, you have to watch, means you have to satisfy the tetravalency whether double bond is required or not. By that way you can do, but after some practice you will get the idea. Even by looking the molecular formula we can identify whether it can contain double bond or triple bond or not. Okay, so how those things, these things we need to understand. Example, if you are taking the C2H6, the simplest one I am taking, how is the structure? Means it is like our CH3, it is representing carbon, other valency of each of the carbon is filled with the hydrogen. It is like this one. Second, whatever the other thing, say C4H10. Whatever the isomer you are drawing, irrespective of isomer, all the carbon must contain the single bond only. See, the carbon, the fourth carbon may be drawn at this end, or if you wish, you may take the other structure, like the fourth carbon you may join here itself. So here we are getting each carbon is attached with the other carbon with single bond only. Means between two carbon there is no double bond. A student, do you not think this carbon contain one carbon bond here and one carbon bond here? Then it is a double bond. Can you say like that? Yeah, student, can you say like that? This carbon is attached with two carbon, hence the double bond. No, student, this is wrong. I had explained to you, between the two carbon, two pair of electrons have to be shared, then only it will be a double bond. Okay, so it is like this. So it is double bond. It is still the single bond. Here with the two carbon, means single carbon is attached with the two carbon with two single bond. But in the double bond between the two carbon there will be double link. It simply means that. Are you getting like now? So whatever the structure we are drawing, all the structure must contain the carbon-carbon single bond only. This is the thing that we need to keep in mind for saturated. Now coming to the unsaturated. Here, the unsaturated, it must contain at least one double bond and one triple bond or the both. A student, if the hydrocarbon or unsaturated compound contain a double bond, even more than one double bond, or any number of double bonds only, then it is called as alkene. Okay, so that is considered as one category. If there is triple bond, means at least one triple bond or more than one triple bond is present, then that category of unsaturated hydrocarbon is called as alkyne. And the saturated compound, means carbon-carbon single bond, they are called as alkanes. Getting? So you may write, these are alkanes. So alkane is representing group of hydrocarbon or the hydrocarbon which are saturated. We will observe that the general formula means whatever the formula we are writing for whether CH4 or C2H6 or C4H10, we can observe that it is always following the formula. So that formula written in the term of N or any general value is called as general formula. So it has the general formula. If we are taking the carbon N atoms, then hydrogen must be in term of 2N plus 2. So this formula must be followed. Example, if we are taking N is equals to 1, it means what? I have C1H2 into 1 plus 2. Means it is our C1, 2 into 1 is 2 plus 2 means H4. C1, 1 is not written, but the 4 have to be written. So this is called as the simplest saturated hydrocarbon have the formula CH4, and it is what our methane. This already we have written so many times. You can take any one. You may take the 2, you may take the N is equals to 4. What will be the formula? C4 H2 into 4 plus 2. So it becomes C4 H, 2 4s are 8 plus 2 is our 10. This is our butane. Okay, it may be your isobutane or normal butane. So how is the nomenclature, that we will see later. So here we are observing few things, what they are. Saturated, these things you have to keep in mind. Okay, I will not explain this saturated compound again and again, which are falling in which category. So saturated compound or saturated hydrocarbon means the hydrocarbon which contains single bond only. Single bond, you have to keep in mind, we are talking for the bonding between the two carbon. So two carbon contain the single bond, means all the carbon in that molecule contain only single bond. Such group of compound is called as alkane. Okay. Now depending on the number of carbon, the general formula followed is CnH 2n plus 2. Considering N is equals to 1, 2, 3, 4 different names are given. Okay, that name we will also discuss. So this is for this one. There are other property like this saturated compound do not undergo any addition reaction. So those things we will write later. But right now these points are important. While I will talk for the alkane means the group of hydrocarbon, means the group of compounds which are following the formula CnH2n plus 2. It is that. And it is containing carbon-carbon single bond only. So for drawing the structure, I need to draw the single bond between the carbon, and all the valency for any of the carbon shall be filled with the hydrogen. It is that much simple. Okay. So after understanding this hydrocarbon saturated, unsaturated, and their formula, the structural formula can be predicted very easily. So it is this first category called saturated. Now coming to this unsaturated. In unsaturated, we have the two situations. One is called as double bond, another is called as triple bond. Yeah, बोलिए.
सर जनरल फॉर्मूला साइक्लिक एल्केन के लिए भी हो सकता है.
हाँ, साइक्लिक एल्केन का जनरल फॉर्मूला एल्कीन के बराबर होता है. मैं आपको एक ड्रॉ करके दिखाया था आइसोमरिज्म में, बट ये इतना डिटेल आपको नहीं पढ़ना है, नहीं तो मैं एल्केन ही पढ़ाऊंगा 10 घंटे तक. हाँ, उसके स्ट्रक्चर, उसके आइसोमर्स आपको सिंपली हम देखेंगे. बीच में हम दो एग्जांपल लेंगे जहां आपको ये देखेंगे कि इफ यू आर टेकिंग द साइक्लिक, वी विल ड्रॉ मोर, देन द जनरल फॉर्मूला इज नॉट फॉलो. सो राइट दिस इज फॉर ओपन ओनली. आपको डाउट आया तो आप यहां लिख लीजिए, इट इज फॉर द ओपन चेन. ओपन चेन के लिए हमने ये फॉर्मूला लिखे हैं. If we have the cyclic alkane और cycloalkane, यदि आपको चाहिए तो मैं लिख देता हूं, नोट फॉर cycloalkane. देखिए यहां दो हाइड्रोजन बॉन्ड टूट के दो कार्बन कनेक्ट हो गए हैं. Obviously the two hydrogen have to be removed. The formula becomes CnH2n. Example देखिए, अभी मैं आपको दिखलाता हूं. But here we need to keep in mind how much carbon we need to take to make a ring. At least n must be greater than 3. Okay, or greater equal 3. If you are taking this as 2, it will always be the linear, and that will be the alkene one. So you may see like this: carbon, 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 carbon. It is the cyclic one. So for fulfilling their valency, 2 hydrogen can be put at each of this carbon. Consider this. What we are getting? The formula is our C4H8. Okay. Though this CnH2n, it is for the open chain alkene. So more details are not required. You just anticipate by drawing the structure. That is the tool I have given or I have suggested you. So better, the best idea, you just fulfill the valency of the carbon and draw the possible structure. By that way, you can anticipate whether this is possible or not. So this is one I have taken, I had explained. So it is the cycloalkane where the formula get reduced by 2 hydrogen. Because if there is 2 hydrogen, means 1 hydrogen is attached with this and this, then this bond have to be open. Okay, it becomes linear. So therefore, this 2 hydrogen is being reduced to connect the two carbon. Getting it is this. It is enough for you people. Now let us go for the other category. For unsaturated hydrocarbon, students, here it may be the double bond containing unsaturation or the triple bond containing unsaturation. So the point where it contains the double bond or triple bond is called the site of unsaturation. At this site of unsaturation, the reaction become very convenient. Like addition reaction, it occur very fast. So those things we will learn in our next class. Questions are asked in that one. So considering the double bond, this unsaturated compound can be classified into the 2 categories. One is called as Alkene. Spelling is very important. And another one is called Alkyne. Students, here we have marked Ane. Okay, now it was this one. Alkene. Alkene means the hydrocarbon which contain at least 1 carbon-carbon double bond. This unit must be present. The other may be satisfied with the other carbon or hydrogen, but this unit must be there. For Alkyne, between two carbon, triple bond must be there. Keep in mind, I have drawn here this one, but in fact, it is like this one. Between the two carbon, while it gets connected, two bond is open for this carbon and two bonds are also open for this carbon. Okay, student? So structure whether drawn like this or like this, both mean the same thing. Okay? Or many a time these two open bonds are drawn like this one also. Okay? It is this one. So it must contain this unit. At least one of the carbon-carbon double bonds should present. So alkane must contain at least one carbon-carbon double bond. One carbon. Do not think this is the bond, just it is written as carbon dash carbon. Okay, or in continuation you may write carbon double bond. Double bond must be there. Means what? It must contain this unit anywhere in their molecule. Considering this alkyne, so it must contain at least one carbon. It is read as the carbon triple bond. In symbol form, this may be written as carbon. Draw the triple bond with the other carbon. Considering this, when the double bond is formed, it means what? Two hydrogen of alkane is being replaced by one of the double bond. It means the general formula for their open hydrocarbon will get modified. So write general formula for open ring. It become like our CN, then H2N. If it is the cyclic, then again two hydrogen have to be removed. Okay, those things are not required at your level. Example, if we are taking N is equals to 1, what the formula? C1H2 means CS2 should form. Is it okay by following the formula? A student, rather than this formula is derived from the tetravalency, not the tetravalency is derived from this formula. Here if you are writing CS2, it means one carbon will attach with the two hydrogen only. The two will remain unbonded. So this becomes wrong. Okay? Therefore, this N must be greater or equal to. Okay? This is the condition over this general formula. So one is not possible. So one have to be removed. Is it okay, student? This is one thing that you need to keep in mind. If you take the example, say the simplest that you may write is C2H, then 2 into 2. The N is equals to 2 I am taking. The formula become C2H2 into 2. So it become like C2H4. A structure, here we are getting, surely to satisfy this, at least one double bond should be there so that the 4 hydrogen can complete the tetravalency for the entire molecule or for all the atoms of carbon. It is one thing. So it is this one. Now coming to this alkane. For alkane, here at least one triple bond. So general formula for making one double bond, or sorry, one carbon-carbon bond, 2 hydrogen have to be removed. In alkyne, 2 such bonds are there, means 4 hydrogen have to be removed from the alkane. So the general formula turns into, you have to remove the 4 hydrogen from 2n plus 2 minus 4. So it becomes Cn, but H2n minus 2. It is the general formula that we need to keep in mind. Okay, students? These are very important. Now the criteria, can here N be 1? Between one carbon, how the double bond is possible? Is it possible? So at least 2 carbon is required in this case. Okay, students? So at least 2 carbons should be there. That is important. So here again the condition like N must be greater equal to. This condition is equally important here. Okay, student? Example. Write down the example. These are asked very frequently, student. So you have to understand before going to the reaction. Which one will go, which kind of reaction, it is decided by this structure itself. If you are taking C2, then how much hydrogen? 2 into 2 minus of 2. It becomes C2H2. Here we have taken N is equals to 2, then we are getting this is their structure. How is this? Between 2 carbon, we need to make the triple bond. Then for the tetravalency, each of the carbon have one open bond that will be satisfied by one hydrogen for each carbon. So the structure is like this. There could be the any one. Let us take N is equals to 5. The formula for alkene is C5H2N. 5 into 2 means it is like our C5H10. This we want to draw. How we can draw? I had already explained how to draw the structural formula. You can follow those rules, or you may anticipate that at least only one double bond will be present at any of the 2 carbon and all the other can be filled with the hydrogen. So by knowing this formula or considering satisfying this formula, the structure can be drawn very easily. Students, so here it becomes the 5 carbon. So put the 5 carbon, maybe a straight or branched one. Okay, here we are getting that double bond is there. You are free to put the double bond at anywhere, maybe at the end. So whether putting at the right end or at the left end, both mean the same. Similarly, taking the bond at the carbon which is from between the second and third positions, means like this one. Even if you are taking the double bond here, it will be identical to placing the double bond here. So any one places you can take. So this way the isomer get developed here. Let me keep this double bond here itself. Then other have to be filled with the hydrogen. See, complete the hydrogen. 1 hydrogen, 2. Is this okay, student? Yes or not? A student, here we are getting, there is some error. Where is the error? Error is that this carbon have now become the 5 bond if you are putting this like this too. So these have to be removed. Okay, no? So you should be careful while drawing the structure of alkene and alkyne. So this is the structure. It's very simple. It may be the branched one also. Branching may be at the double bond or maybe at the single bond itself. Okay, that is also possible. That we will draw later. A student, coming for this alkyne group, let me take one example for the alkyne also. This was our example 1. This was 2. Let us take C3, means N is equals to 3 for alkyne. Come to the alkyne. N is equals to 3. What will be the formula? C3, then H need to be put 3 into 2. So it is like our C3H6. How will be the structure? Very easy. 3 carbon. At any of the position, you are free to put the triple bond. We are going to draw the alkyne structure. It is also possible to have double bond. That become a structural isomers. Not a structure, rather it become a functional isomers. Okay? Those things you will learn in higher standard. Satisfy the valency. The hydrogen, 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 and one more hydrogen here. No, otherwise it become pentavalent. Yes.
Some minus 2 is not.
Yeah, there is -2. -2 is missing. Means it is being not printed here. -2, yeah, it is also C4, H4. So 3 to the 6 -4 is our H4. Okay, student? It is this. So it is our C4, sorry, C3H4. This is structure. I have drawn as C3H4. You can count. So with the 3 carbon, there is 4 hydrogen. It is this structure. Okay, student? So this way you can anticipate the structure also quickly if you have the idea of this. A student, considering the structural isomers, this may also be drawn like this. C, C, C. Rather than this triple bond at one position, I may draw the double bond and I may put the hydrogen at these two ends. See? But then these two are isomers of each other. But in this case, the functional group have changed. Here it is the triple bond, here it is the double bond. So from alkyne to alkene, it have changed. So these are called as functional isomer. These things are beyond to your scope. So I need not discuss this thing. But you must keep in mind, if it is asked for the structure, this structure is also possible. Getting now? So these are also the isomers. But this one, if the double bond, more than even one double bond is there, so this is the alkene. So it is in the alkene category. It is basically the dialkene, means 2 alkene or 2 point of unsaturations are there. So do not get confused at your level. At your level, what are the example I am taking, what are given in the book, they are sufficient. Because this organic compound itself is a very big subject. Like your mathematics and physics, or your chemistry, or even biology, this organic compound itself is very big. But it is very much tricky. Once you understand the concept, everything can be understood very easily. Okay, so do not get confused with this one. You can leave this structure. But if it is asked, then you may understand it could be the isomers of this one. So this was all about our alkane, alkene, and alkyne. Just what is the difference that I have written, means based on their structural formula and their general formula. But there are so many differences that we will write later. Like this alkane do not undergo any addition reaction, but alkene and alkyne can undergo addition reaction. Alkane undergoes this substitution reaction, means one of the hydrogen may be substituted by the other group. But alkene and alkyne, they do not prefer this substitution. So there are various other properties. Those things we will also write later. So as students, here we have learned about the hydrocarbon. Now coming back to the other end. Other end is our derivatives. Whatever the hydrocarbon we have learned that contain carbon and hydrogen, there may be double bond, single bond, maybe your cyclic, maybe aromatic, forget everything. So whatever the kind of hydrocarbon is available with you, in that hydrocarbon, if you are removing one of the hydrogen by any other group of atom or any single atom, means other than hydrogen, then it is called the derivative. Example, write down the example. The example are like this. We are knowing that the formula of methane is CH4. Okay, the structure of methane is like this. 4 hydrogen are attached with the 1 carbon. But if any of this hydrogen is replaced by any other atom, say maybe the chlorine or bromine or iodine or maybe the OH itself, then it becomes a derivative. It's so simple. So example, if I am writing CH3Cl, why Cl is written separately? This Cl represents the chlorine. Their structure is like this. See, with this we have to put the 3 hydrogen, and at any one of the position we can put the chlorine. Okay, so it is called as chloromethane. What was the methane? In that one of the hydrogen is replaced. So naming is again based on the functional group or how or what are their parent alkane or parent chain. So those nomenclature we will learn later. I think we shall start tomorrow. Otherwise, if I start today, I may have to go up to 12 o'clock. So I will not go for nomenclature today. So let us understand this about this derivative a bit more. So how derivatives are obtained and what are the important derivatives that we need to keep in mind, and that will be asked in your examination. A student, rather than this, even if you are taking this in place of this chlorine, last day we have learned it can be replaced by the OH group also, then it will form another kind of compound. So if I am taking CH3OH, their structure is like this: C, H, 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 and at one of the location, it is our OH. OH may be placed anywhere, so do not get confused. So this is called as alcohol group derived from the methane. So it is written as methane. From this, you have to drop this E and you have to write OL. This we have learned last day. Students, do not forget the things that we are discussing on our previous day, because on every next day, whatever the concept we are learning previously, that will be used. Okay. So nomenclature of alcohol, ketone, aldehyde, carboxylic acid, what are the functional group, what is the structure of functional group, and how it is named, that trick we need to use here. So E have to be replaced by OL. So this is called as methanol. Methane, E should be replaced by OL. So methanol is this one. Are you getting? It is like this. So this is the structure. So this is also a derivative. Are you getting? Means what? From the hydrocarbon, if one of the hydrogen is replaced by any other atom, means other than hydrogen, here we are getting it is replaced by OH, means a group of atoms, then it will produce the derivative of hydrocarbon. Now, which derivatives are important for us, that we need to go. Students, please mark it. We avoid confusion. Up to this much we had written for this one. Group attached. Let me write it here. So methyl group attached. So these are very important things. Student, do not forget, because next time we will go for the reaction. Unless or until you understand the type of hydrocarbon, you cannot understand the reaction of these organic compounds. Now, regarding the hydrocarbon, based on their point of saturation or unsaturation, we have classified as alkane, alkene, and alkyne. I have just written their general formula and few examples. How is their naming? What are the reactions? Those things we will learn later. How this unsaturation are conformed, we will learn. Both of these means double and triple bond that can be conformed by a test or a reaction called bromine water test. Bromine water means it is Br2. This is liquid, brown in color. So if you add over the unsaturated compound, the color gets faded. So if the color fading, that is called as the bromine water test. So bromine water test. It is applicable for both alkene as well as the alkyne. How is that reaction? Those reaction we will learn later, student, not today. Okay. Those things, but it is important that bromine water test is applicable for both. So it is for both alkene as well as the alkyne. It is very important test. Every year it is asked almost, or in NTSE every alternate year such a questions are asked. When it will go for dehydration, when it will go for the addition, those things. Unsaturated hydrocarbon or compound were divided into alkene and alkyne. Both have this characteristic. A student, now let us go for the derivative of alkane. So what is asked? I will write that much only. Very few of them I will write. So write derivative of alkane. This I am taking. Example, if we start with the simplest one. The simplest one, this alkane, the general formula is CnH2n plus 2. Tomorrow I will write the entire 10 structure, their nomenclature, considering the number of carbon atom, what is the name, that we will do tomorrow. So for today, whatever and how I am writing, just you remember up to that much. Tomorrow you are able to understand it a bit better. How I am naming it and what is the structure. Those things after tomorrow you will get some more confidence. So consider n is equals to 1. The structure become C1H of 2 into 1 plus 2. So the formula is our CH4. Okay, student. This is simply called as methane. Keep in mind. Now, the structure of this methane is very important for you. The structure only 1 carbon, 4 hydrogen, that is satisfying the tetravalency of this carbon. It's okay. So this is the structure of methane. It is possible to replace one or more hydrogen from this alkane. Then we are getting its derivative. And one of the derivative that you have to keep in mind is replacement of this hydrogen by the halogen chlorine. Okay, that one. So right here, one or more hydrogen of alkane. It is basically, we shall take this methane or ethane, they are most common, but it is applicable for everyone. Let us take the methane here. Can be replaced by halogen atom. Halogen is one of the functional group that we have learned. Halogen group may be your fluorine, but fluorine are not most common. So maybe your chlorine or maybe your bromine, maybe your iodine, but chlorine and bromine are most common. For this removal, what we need to put? We need to put the chlorine gas in this methane gas. Do you think just adding the chlorine gas, means chlorine is also in the form of gas. This is the chlorine gas Cl2. This is the methane gas CH4. You just mix it together, you will get this. Means you will get the hydrogen of this methane replaced by chlorine? No, no, no. That reaction will not. For that, some catalyst is required, or some condition or additional condition is required. So what is that? The condition is that these two can react in presence of ultraviolet light. Ultraviolet light gives the sufficient energy for their activation. Even in many a place, only the light is written, but the best one or the better one is the ultraviolet. Because in question or in many examination, it is asked which part of light. So, right, one or more hydrogen of alkane can be replaced by halogen in presence of UV ray. Even if we consider the sunlight contains some amount of ultraviolet light, this can also occur. Okay, so that's why sometimes only light is used. So what is going to happen? Understand, student, this chlorine means if you are considering the methane CH4, in this you are going to add this Cl. Student, how this bond Cl is formed? This we can get from the Cl2 only, because Cl with one electron free or just as one bond, it is not existing in nature. It is formed during the reaction. Okay, so for reaction we need to write the chlorine itself in their molecular form Cl2, and you are putting the ultraviolet light. The ultraviolet light may be represented by H nu or UV ray. What way you are writing? Many a time, just putting the arrow here means the curved line here. It is also represented like this. It is light is coming here. Any kind of representation is okay. Then it is found that very first from this, one of the hydrogen will be replaced, means CS3 by chlorine. What will be the other? The other you may get HCl. It is possible hydrogen is being taken by this chlorine. It is also possible that this hydrogen again get replaced by H2 and chlorine will be as Cl. It is also possible, but mostly this HCl we shall write. Okay. Student, how is this happening? That we have to understand. Student, this CH4, for this you have to draw the bond structure of CH4 as C with 4 hydrogen. Chlorine, it is also chlorine single bond formed by sharing of one pair of electrons. Now what is going to happen? This hydrogen or one of the hydrogen of methane is being attacked or attached by one of the chlorine. So this is being replaced. It will come out and this chlorine will come and sit here. Ready? This is called the mechanism of reaction. So ultimately it is able to form the other hydrogen remain at their position, and this bond Cl will be come here and HC. So drawing the structure, then you can quickly understand what could be the product. That is another beauty of our organic compound. Students, for this reaction to occur, we need to write here ultraviolet light, UV ray. Or in presence of light, this reaction can occur. Here, if sufficient amount of chlorine is present and further more UV ray is present, means more Cl2 is available in presence of UV ray, then the other hydrogen can also be replaced. It is able to form Now you may take this hydrogen or this hydrogen or this hydrogen, any one. Means it is occurring step by step. It become like C, then Cl, H, H, Cl. Furthermore, if more Cl2 is present, what is being added? It is written here Cl2, okay, over this arrow itself. UV ray, the other hydrogen will be replaced. So a structure we need to write it here. So it become like this: H, one of the Cl, Cl, Cl. Furthermore, if more Cl2 is present and UV ray, even whatever the remaining one hydrogen, this can also be replaced, and the structure become like this: Cl, 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 Cl. So this is the reaction that will occur. A student, in this case or in this reaction, few important things you have to keep in mind what is asked in your examination. A student, it is asked what is the name of this. So name of the very first compound which is formed here, this one, chlorine is there. So the name start with the prefix chloro, and it is from the methane. So name will be your chloromethane. So it is our chloromethane. It is important, student. Coming to this, what will be the name? Same chloromethane, is it okay? But chlorine is present 2 in number, so the term di is used. Dichloromethane. Okay, student? So this name are important. Another one coming here, 3 chlorines are there. It means I shall use the prefix as tri in place of di. So it is called as trichloromethane. And here it is the 4. So for 4 we are using the term tetra. So this is called as tetrachloromethane. It's also okay. But I will give the other name also. So tetrachloromethane. See, no hydrogen is there, so sometimes it is also called as methyl tetrachloride. Tetrachloride means from the methyl group 4 chlorine is being added. So tetrachloromethane is written or methyl tetrachloride is written, both mean the same thing. Okay, so wherever only one prefix with the halogen, sometimes also used as suffix, but this one is most acceptable as per our UPSC. This one is called as the common name. Okay, student, it is our common name. This is our IUPAC name for this compound. Okay, so whatever we have written, tri, di, chloro, all these are our IUPAC name. It is one thing. A student, the another important thing that we have to keep in mind is regarding this structure. Okay, this is very important structure, and we are coming across our laboratories in our school so many times, in biology, in chemistry. Okay, and you might have heard about it. Can you recall it? It is called as, or commonly called as, chloroform. So whatever the chloroform we are using as anesthetic, okay, in our chemistry to make this frog hibernate or to sleep so that operation can be done, it is this chloroform. It is one thing. So this chloroform is very important. A student, chloroform, why it is important? So write this. Chloroform. Molecular formula wise, the structure is like this one. It is our C, H and Cl should be 3 times. It is one thing. So remember this formula. Remember this structure. It is very important. Another, its application. Why it is important? We are coming across many application. So that's why it is important. The very first is as anesthetic. It is one thing. Means anesthetic during the operation. But this chloroform is not used for the operation of the patient in our hospital. Okay, there are some different gases are used because excess smelling of this could be the lethal one or may dissolve with our blood. Certain problem arises. So it is used in medical to a limited extent or in our lab also. The another important property is it is a good organic solvent or a good kind of preservative. If you have to preserve anything which is going to be decayed and you are placing that material inside this chloroform, it will not decay. Okay, so it is a good preservative. Another one is it is good kind of organic solvent. This used for preservative or storing something or as a polar solvent, means dissolving the polar material. Like the grease that you are getting, the grease cannot be washed away with normal water. Why? Water is polar, but these grease are non-polar. Okay, so that's why it cannot be washed. But if you are taking some amount of the kerosene oil or some amount of diesel in your hand, then you are rubbing, you are absorbing that, the grease start leaching out from your hand. Why so? Because these hydrocarbons are non-polar. So this thing can be used. This can be used as a solvent. Wherever non-polar solvent is required, we can use this. Non-polar solvent may be used for storing or dissolving the non-polar or organic compounds. You will learn more in your higher standard. So as non-polar, this non-polar is also called as organic. So use the term organic also, or organic solvent. So wherever we have to clean some of the grease or any organic dirt, we can use this. Okay, it is like this. So these two are the important application. For that purpose, it is frequently asked. Mostly the common name is given and you will be asked for identifying the structure. So this is chloroform, you have to keep in mind. So chloroform have more importance. A student, this organic solvent, mostly it could be the chloroform like CaCl3. Even this is also a good kind of organic solvent, carbon tetrachloride, or maybe your CCl4. Both are used as organic solvent. So this is used as organic solvent. Or preservative sometime, means the organic preservative if we need, we can use it. Organic solvent or organic preservative. But not preservative for the polar substance. So this thing you have to keep in mind. So the importance of carbon tetrachloride and chloroform, their structure, their formula. Once it was also asked, what is the IUPAC name of this carbon tetrachloride? Yes, what is the IUPAC name? It is, the option was given methyl trichloride or trichloromethane. So you have to follow, or you have to mark the correct option considering the IUPAC, where this chloro is used as prefix. So it is our trichloromethane. This is the IUPAC name. This is IUPAC name. This nomenclature we will learn tomorrow. It was this one. Dichloride, not much important. And this chloromethane, just for the understanding. So this was all about. Let us stop the class here itself. Otherwise, yeah, it is 10:30 o'clock. Otherwise, if we start the other topic like unsaturated, then it will take another 1 hour or even 2 hours. So let us stop. Let me stop it here. Student, it may be possible that this hydrogen of methane may be replaced by the other one. It is also possible to replace one of the hydrogen, this hydrogen, by the other group, like OH. Take this as the OH. Now, how this OH? Again, there are certain kind of reaction. Those reactions are beyond to our scope. It's not required for at this standard. We will learn in higher standard. This is called as what? Methanol. This structure also you have to keep in mind. Okay. This methanol have medicinal use, used as medicine. A student, keep in mind, methanol is not used for drinking. If anyone is drinking methanol, then he becomes blind. The nervous system is heavily damaged by this methanol. This ethanol means C2H5OH. This can be used as a beverage or drinking purposes. So this ethanol is also for the medicine. Other one is the drinking or as the beverage. Right, at drinking. It is. Other one is, this is used as additive in our petrol. Additive means in petrol 5% of this, say in 100 liter of petrol, 5 liter of this ethanol can be added. That gives better performance to the vehicle. Okay. In addition, the depletion of this natural resource like petroleum can also be reduced. So used as additive in fuel. This fuel like our petrol. So additive in petrol. In petrol, 5% of this is added. Many more applications are there. For ethanol, these are important. Later on, we will also discuss. So let us stop the class here itself. A student, any doubt, then please ask. So today I have explained about what is hydrocarbon, type of hydrocarbon, and their derivatives. This much. Next day, we will continue with the nomenclature of this. Means nomenclature of this hydrocarbon, and if the functional group is there, what should be the suffix or prefix used, that we have learned. So using that, we will write some more name of some more compound. Okay, student? Yes, student, tell me any doubt, then otherwise let me stop the class here. Please do the homework that I had given you earlier. I think today we cannot do any new topic as homework. So tomorrow I will try. I have already finished the chapter of class 9th. So I think tomorrow we are able to start on time your class. Okay. So please do the homework. A student, for the homework, please revise your maths. Please revise your maths. Do not forget. For this revision, you need to go through the two things. One is your textbook. Another one is your exemplar problem. So I think at least you shall revise one chapter. Chapter 1, please revise completely. Then if you get the more time, whatever our booklet I have given to you, RC booklet, from that you do the question, because that contains the previous year question. It is that one. So please do this revision, and please read this chapter from book. Read carbon and its compound from our textbook till now. Till this hydrocarbon, now you are able to understand. I hope.
Sir.
Yes, tell me.
So can you show the last slide?
Okay, just wait a minute. So students, these things are very important. You please understand this carbon compound in the class itself, because by reading the chapter, you can never understand this carbon and its compound, because in our textbook, it is written in very compact form. So no one can understand. That's why only the teacher can make it clear. I have posted your homework also in our group. A student, I was writing this one regarding the methanol. You have to keep in mind it is used in medicine. Regarding the ethanol, you have to keep in mind the three important uses. Regarding this chloroform and other thing, it is formed by. So what is the condition required? UV ray is required for removal of hydrogen by halogen. So chloromethane, then dichloromethane, then trichloromethane. Trichloromethane have the common name called chloroform. Chloroform is very important. It is used as anesthesia for anesthetic purpose, as well as the organic solvent for dissolving the organic compound, or as the preservative for the organic things. Next one is the carbon tetrachloride or tetrachloromethane. Tetrachloromethane is the UPSC name, and methyl tetrachloride is the common name mostly for this. Yeah, tell me, what do you need? Anything more? Written?
Yes, sir.
Okay, student. Any doubt to any student, then they may ask. Otherwise, I am going to stop the class. Tomorrow